Hello, we are team behind CabVector. Ayush, Anup, Dhruva, Ishant, and Rehan. CabVector is an NYC MTA preemptive taxi staging system. Its goal is to help taxi operators respond before a transit disruption creates long passenger queues and local congestions. Instead of acting like a booking app, CabVector detects a meaningful transit delay, estimates displaced passenger demand, recommends a nearby taxi staging zone, and keeps an operator in control of the final dispatch decision. On the operations page, the map shows the active disruption, safe staging zone, and taxi positions around the affected area.
CabVector's fast API backend combines MTA subway, GTFS real-time data, MTA bus time SIRI data, NYC dot traffic speed data, and historical station footfall fixtures. A delay must persist before it becomes a disruption. The system then calculates an L score from passenger spill and footfall. An L score above 70 allows the fleet workflow to begin. The backend exposes state, provider health, simulation, custom disruption, and live event endpoints. The dashboard polls the latest state, displays provider status clearly, and receives decision events through server sent events. If a provider is unavailable, CabVector reports the status and safety retains its fixtures backend behavior rather than pretending live data is available.
Our dispatch workflow is designed with safety checks at every stage. First, the fleet agent selects suitable taxis. The request is then sent to the traffic agent, which evaluates congestion around the staging area. If the congestion level is greater than 0.7, the dispatch is rejected and taxis are not moved. Only when traffic condition acceptable does the backend update the taxi's rate. During development, we used Codex with GPT 5.6 as an engineering assistant. It helped us organize the implementation, connect the front end and back end, improve documentation, and verify the application through testing and production builds. However, it was only used during development. The live dispatch decision always follow our deterministic, transparent, and human-provided workflow.
Now we will demonstrate the workflow. Here we can inject a custom disruption by selecting a major station and the L score. The map updates to the new incident and the dashboard shows the disruption hub, projected the impact, by simulation, a staging zone, and scattered taxi fleet. When we select or run agent simulation, CabVector evaluates the disruption, proposes taxis, checks safety services, and records the outcome in the event stream. The fleet matrix and map markers make the taxi state easy to understand, available, proposed, or dispatched. We can also navigate to fleet, zones, incidents, dispatches, analytics, providers, simulation settings for focused views of the system. CabVector demonstrates how real-time mobility data, clear safety rules, human oversight, and AI-assisted development can work together to make urban transport response more proactive and explainable. Thank you.